Hello friends, welcome to our channel Knowledge Amplifier. So today in this particular video, I am going to discuss about record columnar format, which is one of the very important concept related to big data domain. Okay, what is this? What is the internal mechanism? All these things I am going to cover. Okay, so if you have some fundamental idea about big data, then I hope you have heard about 3V. Okay, which is one of the major characteristics of big data. Okay, one V is called volume, another V is called velocity, and another V is called variety. Okay, so in big data domain we basically handle different variety of data that can be structured, semi-structured, unstructured, different. Okay, then velocity. Okay, the data might be coming with some velocity like streaming data and all. Okay, then one of the most important characteristics is volume. In big data we basically handle huge volume of data. Okay, and to store this huge volume of data we cannot simply use our normal file format. Okay, because that will be stored as uncompressed file and that will take huge space. Okay, so to overcome that particular storage issue, scientists came up with different compressed file format, and among different file formats which are widely used in big data domain for compression, RC file format is one of the most important part. Okay, that is record columnar format. So what is that? I am going to discuss. Okay, so see, you just considered this is a table and this table has 3 columns X, Y, Z, and these are the row values. Okay, now there are two different type of database storage we can consider. One is row oriented database, another one is column oriented database. Okay, so what happens for row oriented database or row format type? That is, data is stored row wise. So you just consider this first row. The first row is basically coming here. Okay, here if you see this particular place, here is the first row. If you consider second row is coming here. Okay, this particular place. Okay, this is the basically second row. So in row oriented database, first column of a row will be next to last column of a previous row. Try to understand the definition. Okay, so first column of a row you consider the second row. Okay, and what is the first column of the second row? That is x2. Okay, and what I am telling, first column of a row, that is this x2, will be next to last column of the previous row. So previous row is this first row. What is the last column? Last column value is z1. Okay, so see, x2 is basically after z1. Here you see x2 is basically coming after z1. Okay, so that is the definition of row oriented database or row format, where data is stored row by row, and in other way we can say first column of a row will be next to last column of the previous row, and this is how the data is stored. Okay, now here what is the advantage of this kind of data storage? That suppose I want to insert another row. In simple way, if I want to execute one insert query here, suppose for example this will be x6 and this will be y6 and this will be suppose z6, then simply we can store in the backend. Just we need to go here, and here we will be putting x6. Okay, we'll be having one extra block, and then here we'll be having y6, and here we'll be having z6. Okay, so this kind of insert is very simple in this kind of row based formats for databases, right? But what is the issue? So if you consider, the issue is present in performing aggregation. Okay, I hope you have already studied aggregation in SQL. So basically, if you suppose want to apply aggregation on a particular column, suppose maybe for this particular y column you want to do some kind of aggregation, sum or average, something like that, then as the data stored in like this way and your only interest values are like this, I'll be showing with different color. So y1 value you required, okay, then this y2 value, and then y3 value, and then y4 value, like these values only you require. But to get that, starting from beginning, you have to start scanning this particular whole sequence and you have to accumulate those values. Okay, so that is with respect to performing aggregation point of view, this is not efficient. It scan the extra data, okay, that is unnecessary other columns on which we don't want to execute the aggregation. Those column data also it is basically scanning, which is basically making the whole operation slower. Okay, so the conclusion is, in performing aggregation, row oriented database is not good, but yes, we have seen that inserting data it is very good. Okay, with respect to writing data point of view, it is much faster, right? Okay, now if you consider our nowadays data warehouse system, any well AP online analytical processing related system, where basically we are having huge volume of data and we want to get some business insights from the data, that time we often use different aggregation on different columns. On a particular column we are calculating sum of all the values, on another column we are computing some other aggregation, right? So those aggregation point of view, as this particular row oriented database is not good, that's why scientists came up with another database storage, that is column oriented database storage. Okay, and that looks like this. Okay, so what happens in this particular case, that is each row of a column will be next to other rows from the same column. Okay, try to understand. See, if you consider this particular column format data storage, what I told you, each row of a column. So suppose you consider first row. Okay, so if you consider this X column, the element is X1 for this X column, right, for the first row. So each row of a column, so that is this X1 value will be next to other rows from the same column. Okay, so see, in the same column X, the next value is X2. So X1 and X2 we are putting side by side. Okay, that's what definition of column format data storage or column oriented database. That is each row of a column will be next to other rows from the same column. And now you see the advantage. If you store your data like this way, then what will happen? Then performing aggregation based on a particular column will be very easy. Suppose for example, you want to do aggregation on this Y column, then once you reach this particular part, then you no need to scan unnecessarily the Z values also. Only the Y values you can take and then perform aggregation whatever we are putting in our SQL query, right? So from well AP aspect or analytics aspect in big data system, this column format data storage is very helpful. Not only that, I will tell you another interesting part of this column oriented data storage. That is, you consider this kind of data storage in the backend and you consider this one. Okay, so from the basic intuition itself, you can understand that the values present in the same column, there is a probability that they will be having some repetitive nature, right? Like for example, suppose you are having a table which is containing list of friends in Facebook account, then suppose you are belonging from India, then there is a huge probability that for the country column, consecutive multiple values will be India, because you might be having many friends from India only. Okay, and that time in the backend, if your data is stored like this column format, then you can use different compression technique like run length encoding, which is one of the very important lossless compression. Like for example, I can tell you how run length encoding works. Basically, suppose India is denoted by A. Okay, so suppose you are having 4 friends which are basically entries of this particular table, I can say, and all are A, that is all 4 are consecutively belonging from India, and one more friend from USA. Okay, that time instead of storing in the backend data like this way, you can store like this way, that is 4A 1B, which will indicate while decoding the code, or the compiler will easily understand that okay, this is a compressed format, run length encoding has been applied. So while decoding, so it is meaning that 4A are consecutive to each other, then 1B is present. So this kind of lossless compression also you can perform for this column oriented data storage, okay, or column oriented database. What is the reason? The reason is simple. Like from the fundamental intuition itself, you can understand, right, that repetition in this kind of data storage will be lesser compared to this particular one. Here in this kind of data storage, there is a huge probability that the data will be repeating in the consecutive values, right? So that time you can apply different compression technique. Not only that, I will tell you another interesting compression format. Okay, that is, for example, suppose you consider this particular table, okay, which is having date and then user and then orders, okay, right? And now suppose you are basically using the column oriented database storage type, and then what will happen? This particular value and then this value and then this value and then this value, these four values will be consecutive to each other. So that's what is written here. See, all the rows belonging to same column, okay, are having consecutive values. Then John, Jane, Alex, Emily, okay, all are consecutive, okay, and then these values, okay. Now here if you see, date is taking a huge space in your disk, okay, because it can take many number of bytes for individual cells. And now you can apply compression on the date. What you can do, suppose for example, instead of storing this kind of timestamp format, you just consider this particular date column. I have just taken all the values consecutively for column oriented data storage, and then what I will do, I will basically convert them into Unix epoch format, okay, which will basically show you the offset or number of seconds passed from, that is this timing, that is 00 colon, that is 00 hour, 00 minute, 00 second, okay, UTC for 1st Jan, okay, 1st Jan, that year is 1970, okay. That format is called basically epoch format to store the timestamp. So from this, how many times passed in seconds, that kind of format you can convert, okay. And then this becomes basically integer. So from date, which is taking maybe 10 bytes for different cells to store the data in the disk, you can convert that to integer, and that may take only 4 bytes to store. That way you can compress, okay. Not only that, you can go one more level, and what you can do, you can just store the first value as it is, and next value onwards you can store like delta in encoding format. Like for example, first value I am putting as it is. To get the next value, what I will do, I will basically add these two, okay, that is plus 360, which is basically indicating that you add these two, you will be getting second value. To get the third value, you add these three and you will be getting third value. So like that, this is called delta encoding, okay. So delta encoding you can apply, and then instead of storing the date as date format in the disk, you can save the disk space by storing into integer format, like this kind of delta encoding, right? So all this kind of compression you can apply if your data is stored in column oriented format, because the advantage is each row of a column will be next to other row from the same column. So if there are some amount of correlation in between different values of a particular column, okay, then you can put this kind of compression and you can save the memory, or you can use your memory efficiently, right? Maybe if there is some string type column, then you can apply run length encoding or some other encoding, dictionary encoding, different encodings we have studied in our BTech information theory and coding course, right? So all those you can apply in the backend, okay? So this is the advantage of columnar data storage, column oriented database, okay? Now there is obviously, if some advantage we are getting, then some drawbacks also will be getting. Like suppose for example, your data, this particular table is stored in this kind of column format, then suppose you want to display select star kind of thing, then what you have to do to show that, you have to scan this table, and suppose the first row you want to generate in the result set, then first value will be getting from here, okay, and then to get the next value I need to reach here, okay, then I will be writing the next value, and to get the value of the last column I need to scan till here, and then only I will be getting the last value of the first row, okay, or basically this particular value what I am talking. Okay, so this way if you understand, suppose for x2, then again it will start scanning and then it will be taking x2 value here, then it has to scan the complete part, then it will be getting y2 value and put here, and then again it has to scan the complete part, then here it will be getting z2 and it will be writing here. So this way it is becoming inefficient. So if you are applying select star kind of thing, then this becomes problematic, right? So to overcome this particular problem, scientists told that why to use this kind of columnar format on the whole data. Instead of that, what we can do, we can split the data into small chunks, and there we can put this kind of columnar format. So if we have to regenerate this particular columnar format to table due to select star or those kind of queries, then we can easily do that in a faster way. So what is that? That is nothing but like this way if you consider. So this is our main table. Okay, so you see row oriented layout will be how it will be looking. So 1 2 3 will be first, so here 1 2 3 coming, and then 4 5 6 will be coming next value, here it is there, then 7 8 9 here it is there, and 10 11 12 here it is there. So this is how row oriented layout works. How column oriented layout will work, that is 1 4 7 10. Once all the values of the first column we will be writing, then the next column will be writing. So that will be 2 5 8 11. Okay, and then we'll be writing the last column, which is basically here I'll be giving semicolon to make differentiate, 3 6 9 12. Okay, now in this kind of storage, what is the problem I have told you? That is, suppose if you are applying select star kind of thing, then scanning is a big problem. So instead of that, what we can do, we can basically split this whole table into small chunks. Okay, see what we can do. Suppose we will be making these two rows as one chunk and these two rows as another chunk, and then we will be applying this column oriented layout for our data storage. Okay, so how it will look, I'll be showing you that. So first let me erase all this. Okay, right. So what I told you, there is first two values will be grouped together, next two values will be grouped together. So you just see this particular data storage column oriented layout. Okay, so see, it is called row split 1. So on row level we have split it into small partitions. So in the row split 1 we are considering first two rows, row 1 and row 2, and on this particular row split only we will be applying this column oriented layout. So how the data will be stored, 1 4 will be together. Okay, and then 2 5 will be together, and then here 3 6 will be together. So this is a separate block if you consider row split 1. Then another split or another partition is basically this particular row split 2, where row 3 and row 4 are stored. Okay, how it will be storing in columnar format, that is 7 and 10 together, and then 8 and 11 together. Okay, and then 9 and 12 together. Okay, so like this way. Here we are just kind of following some middle approach. It is neither exactly row oriented layout where basically we cannot compress at all, and it is not completely column oriented layout on whole table. Instead of that, we are making partition into small chunks, and then we are applying column oriented layout. So what will happen? So suppose now you are doing select star, then to generate the result set, I will be taking one value here from here, then here I will be taking 2 value from this one, and then here I will be taking 3 value from this one. Okay, suppose I want to generate the second row, basically I will be taking the second value from here while scanning, then I will scan till here and then take the 5 value for the second element, and then I will scan till here, then I will be taking this element. Okay, this way what is happening here, we need to scan a lot because the complete table is now, in this case it was present in columnar format, but here we have to scan but not that much. Okay, so this is the advantage, that what we are doing basically in the first step. In the first step we are splitting the whole table into small partitions, where in individual partitions there are some rows are present, which are basically we are giving the name row split. Okay, then on the row split we are applying column oriented layout, and that is nothing but called RC file, or in other way we can say record columnar for file format. Okay, whole story we can summarize in this particular slide. That is record columnar format, one of the very important big data storage with compressed file format. How it works? First step, split rows into row groups, which we are telling row split, and then transpose values within row group. Okay, so maybe if you are considering this is our input table ABCD, then we are considering a small chunk or row group, and then this is our HDFS blocks, and all these rows are going to one particular row group, and in that row group, see here we have done transpose. Okay, see 101, 102, 103, 104, 105, all are coming together. Okay, then 111, 112, 113, 114, 115 are coming in the second row. That is basically after splitting into row groups, we are applying columnar data storage concept. Okay, and this way now in these particular values we can apply run length encoding or delta encoding, all these things. Okay, and make storage optimize. Okay, so this is how we can compress large volume of data and put it in a small storage system. Okay, so I hope you have understood this particular concept. So nowadays many OLAP system, cloud warehouse, like for example Redshift, Google BigQuery and Snowflake are using this kind of column oriented database storage to optimize the storage. Okay, and in OLTP system, where basically we are mostly focusing on insert or something instead of focusing on business analytics, where less amount of aggregation required, that time you can go with row oriented database. But if you want to do aggregation to get some business insights from the data in the cloud warehouse or in your big data system, then this kind of column oriented storage is very efficient. Okay, so I hope you have understood this. This is all for this video. Thank you for watching.